The inspiration to our project of semi-autonomous water surface cleaning robot comes from the fact that the Ganga River is in a very poor situation right now. One of the holiest and the oldest river in the world is becoming a dump yard of garbage. The water is so polluted that people are not even able to survive around it. Government's initiative like Namami Gange project is in the path of cleaning Ganga River. Us as student and group of Capstone project want to add some value to that project by creating a prototype of water surface cleaning robot. The board design that is present on the screen in the front is the initial design format that we planned out for the water surface cleaning robot. It was planned initially in a circular format with collecting arms extending out of the front part of the body. The collecting arms were planned to be porous. If the collecting arms would be porous, the water will flow out of the porous arms without creating much drag in the water robot, and the garbage that will come inside the collecting arm will go through the board body and will be present inside the basket, the collecting basket of the garbage. The image that comes in front is the collecting basket. The collecting basket was also designed in a porous format so that the garbage that is collected is just present in the collecting tray, and the water just flows out of the collecting basket without leaving any track. The second image that is present on the screen is the image of the conveyor belt. The conveyor belt was initially planned to be in the again in a porous format with the dimensions as mentioned, and the it will be placed in front of the board body design so that the garbage that comes can be collected through the conveyor belt and is lifted and put behind the board body, that is the collecting basket. The main problem that we identified with the first model was that it was in a circular format, and that would create a high drag, and it would require much more energy from the motor and the battery to push the robot ahead. That's why we shifted to this design on the screen. It was more streamlined. The front of the boat was more pointed, which ensured that the water would cut better. This would require much more lesser power generation from the battery and the motor, and the boat would move ahead more easily. The same has been depicted in the video fabrication that I will show you right now. As you can notice that the body of from the front has been made more streamlined, and the conveyor belt structure has been attached in the front of the model. The whole model is in the shape that has two hulls, and the front of the hull is more pointed so that the water can be cut better and it can be more streamlined. These are more images of the CAD model of the boat model. There are three, as I mentioned, there are three conveyor belt wheels, which is placed on two rods, one in front and one in back. The whole conveyor belt is placed on these three wheels. The motor in the conveyor belt ensures that the wheels are moving in anti-clockwise direction, so that the garbage that is collected from the front is then placed in the basket that is attached on the boat on the back side. And then you can see on the right side of your screen, there are two propellers that are attached on the back side of the boat. These propellers provide the energy for the boat to move ahead. These propellers are fixed with two motors of 12 volt and 300 RPM each. The propeller has been 3D printed in the Thapar Institute 3D printing shop, and the propeller is then fixed on the RPM motor, and it then takes the boat ahead. The same has been depicted in the video of the fabrication model of the boat model. There are two 12 volt and 300 RPM motors, as I mentioned earlier, and there is the conveyor belt in the front part of the boat. It will ensure that the garbage is collected and placed in the basket behind. Apart from the boat body design, we have also utilized electronic components and equipments for motor propulsion and the boat propulsion. These are all the electronic components that we have utilized for boat propulsion. The first component is BTS7960, which is the motor driver, and the second component is ESP32, which is the microcontroller. How we have utilized it is that we have a mobile app that has commands for forward, backward, left, and right. When we press forward in the mobile phone app, the boat moves forward. Backward, the boat moves backward. Left, the boat moves left, and right when the boat moves right. We have also utilized an ultrasonic sensor which is attached in the front of the boat. Whenever the boat encounters any obstacle, the motor stops working and the boat stops in the water. We have also used a temperature sensor which is dipped inside the water and which gives real-time temperature of the water on the mobile app. So we can use the boat propulsion through a mobile app, remotely controlling the boat when the controller can be on the shore and the boat can be inside the river.